If we know the area that the fire covers in square metres and the heat release rate per square metre, and we also have a figure that we can use for chi, then we can derive a maximum expected heat release rate for a fire as shown by this equation. QP is the maximum expected convective heat output measured in kilowatts. Chi is the convective proportion of the total heat output, and AS is the area of the source fire in square metres. Little qf is the heat release rate density in kilowatts per square metre. Here's an example of the equation being used. If we replace chi with the figure of 0.67 and replace the AS, the area of the fire, with 2 by 2, that's a 4 metre square fire, and replace QF, the heat release rate density, by a figure of 600 kilowatts per square metre, then we can evaluate this to give us a value of 1,600 kilowatts. That's the convective heat output of the fire is 1,600 kilowatts. It is very important at the design stage to make realistic assumptions about the future use of parts of the building that will spill smoke into an atrium that has a smoke control system installed. It's sometimes necessary to stipulate at the design stage what may or may not be put into an atrium, and this stipulation must be passed on to the building user on completion of the building. When we consider the location of the fire, it is usually the worst case for a fire to occur as low as possible, as this leads to the longest rise of the plume, leading to the most cold air entrainment and therefore the most smoke. The smoke will also be less buoyant because it is cooler, having entrained more cool air.